So the definition of an exponential function, let's put that right here nicely in this little box. We're going to say that is y equals a to the x. Okay, a is the base. And if a, this value here, that base, is greater than 1, then you have what's called exponential growth. And if a is between 0 and 1, so let's say it's 1/4 or 1/2 or 2/3, something like that, then you have what's called exponential decay. You really won't have an a value that's negative, because then you will not have that constant pattern, because if you, you'll flip from positive numbers to negative numbers when you're raising it to a power. So it won't work out that way. So 0 is the boundary for a, so between 0 and 1. So a fraction less than 1 but greater than 0 is what causes decay. So the points that all exponential functions have will go through 0, 1. And they all have a horizontal asymptote at y equals 0. When we look at a few examples, I think you'll see why that is. And we will talk about what other points graphs always, what they will have. So let's do a few graphs. And I want you to basically graph these using a table. So if you're graphing f of x is equal to 2 to the x, okay? And, when you're graphing using a table, you can literally write down the table, or you can do the table in your head if you're, pretty confident in what you're doing. Okay, so if we let's put in -1, 0, and 1, and then let's put in like 2 and 3, okay, just so we can see what it's really going to look like. So if we put in -1, that's 2 to the negative first power, so that is equal to 1/2, right? If we put in 0, 2 to the 0 power is 1. If we put in 1, 2 to the first, 2. Put in 2, 2 squared is 4. And then this would be 2 cubed, so 2 to the third power, that's 2 times 2 times 2, so that's 8. Okay, so if we graph that, we're looking at -1/2, 0, 1, 1, 2, and 2, 4. Why is this graph so small? And then 3, 8. All right. Now, let's talk about a few of these statements that we made before, right? All will go through 0, 1. Well, that's because that means that you're raising your base to the 0 power, right? So 2 to the 0, 6 to the 0, anything that will always be the point 0, 1. And then second, they will have a horizontal asymptote at y equals 0. Well, I only did -1, and that I got 1/2. But if I did x equals -2, I would get 1/4. If I did x equals -3, I would get positive 1/8. So what I'm getting, I'm not getting negative numbers for the graph. I'm getting fractions closer and closer to 0. So you do have a horizontal asymptote only going in the negative infinity direction, right here for your graph as the graph goes closer and closer to 0. Okay. So this is the y equals 0 horizontal asymptote. All right, let's look at 6 to the x and see how that changes things. So here's x, here's 6 to the x. We have Let's put in -1, 0, 1, 2. I don't even think we'll be able to graph 2, so we'll stop there. All right, when we put in -1, 6 to the -1st would be 1/6. Okay, 6 to the 0 power is 1. 6 to the 1st is 6. And 6, this would be 6 squared. That's 36. That's why I said we're really not going to be able to graph that. So we can graph -1, 1/6, 0, 1, and 1, 6. And then we just know that it goes like shooting up from there. Okay. Sorry about the little dip in my line. So same deal. It's going to get closer and closer to 0 over here on the left, y = 0 line. And then here it's going upwards very quickly, okay, faster than this other graph. Okay. Let's look at one more. Now this is 1/2 raised to the x. And remember, if the base is less than 1, then it's going to be what's called decay. Okay, so let's see why. Here's x, and then 1/2 to the x power. So let's put in -1. Let's put in 0. Let's put in 1. Okay, let's put in 2 and see how we do on the graph, right? So if we put in -1, 1/2 to the -1st power is going to flip the fraction, right? So it's going to equal 2. 0, anything raised to the 0 power is 1. 1/2 to the 1st power is 1/2. And 1/2 to the 2nd power would be 1 squared over 2 squared, so 1/4. Okay, so if I graph those, I'm getting -1, 2, and then 0, 1, and now I'm going into fractions less than 1 but greater than 0. Okay, so I might want to even put in like -2. So 1/2 to the -2 power is 4. If you're real not confident about those negative exponents, of course you can check them with your calculator, right? So, but we'll also be working on them quite a bit in this chapter or unit. All right, so -2, 4 is right here. So if we trace this graph down, we are going in this direction. Okay, so now, as you can see, we are decaying. Our number is getting smaller and smaller, getting closer and closer to 0. We still have this horizontal asymptote at y = 0. It's just that it's on the other side of the graph.